what we have here is a circle, and when we take a bit of its perimeter, we get an arc, which is this little blue bit over here. An arc creates an angle at the center when we join up the two ends in the center, like this. And when we change the size of the arc, the angle also changes its size. An arc can also create another angle at the perimeter of the circle. So when we put a point at the perimeter, like this, and we join the two ends of the arc to this point, we get another angle, which is exactly half the size of the angle in the center. The really cool thing about this second angle at the perimeter is that no matter where the point is on the perimeter, it's still the same size, no matter where we put it. So I'll just show you like with the numbers. So now you can see it's 28 degrees, and no matter where we move it, it's still 28 degrees. And now if we change the size of the arc, both angles change their size as well, and it's still the same size no matter where we move it. Now what we're going to do today is prove that the angle at the perimeter is exactly half of the angle at the center. And now a really good way to do this is to split this shape, the shape that looks a bit like the Star Trek symbol, into two triangles. And the great thing about having two triangles is that we can apply the triangle properties and use some algebra to work out the angles. Now we'll call this angle at the top, we'll call it S for small, and we'll call the angle at the center B for big. And we'll just make the triangles a little bit bigger so we can see it more, and it's a bit more clear. So remember that's B. And what we'll do is because we've split the shape into two triangles, we'll also split the angles as well into two different angles. So we'll call, instead of calling it S, we'll call it S1 and we'll call this one S2. And down here we'll call it B1. And then we'll call this one B2. Now, if we look at this triangle on the left, we can see that these two side lengths, this one and then the one in the middle, are exactly the same, because they both come in from the center to the perimeter. So that just means that they're both radii. So this makes this triangle an isosceles triangle. And remember that the angles opposite the two side lengths that are the same in an isosceles triangle are also the same value. So that means that this angle over here is also S1. And now we've got another angle here, which we'll call beta. We'll call it alpha for now, actually. We'll call it alpha, so it comes first in the alphabet. And now we've got a few angles, so we can actually do some equations. So we know that the angles in a triangle add up to 180 degrees. So we can say that S1 plus alpha plus another S1, but we'll just write it as 2S1, equals 180 degrees. And then we can write this equation as alpha plus B1 equals 180 degrees, because we know that the angle of a straight line is 180 degrees. So we'll write alpha plus B1 equals 180 degrees. And now if we look at the two equations we actually have simultaneous equations, and we can solve them by substitution because they both equal 180 degrees. So we can say that 2S1 plus alpha equals alpha plus B1. And now if you look at the two sides of the equation, you'll see that we have two alphas. So we can just subtract alpha from both sides and make the equation 2S1 equals B1. And we'll just put a square around that so it's not cluttered. Now, we can also do all of these steps that we've done on the left triangle on the right triangle. It's exactly the same steps because it's also an isosceles triangle because the two side lengths are radii. So that angle is also S2, like the angle up the top over there. And then we'll call this angle beta now. And we know that beta plus b2 equals 180. So if we do all the working out we just did for the left triangle, we'll get the equation 2s2 equals b2. And we'll just draw a shape around that as well. So remember how we split up b before into b1 and b2? Well, we'll make it b again, because we want to get rid of b1 and b2. So now we can write b equals b1 plus b2. And then we can also write from the working out we did before that this equals 2s1 plus 2s2. And now we can write this again and simplify it so that b equals 2 at the front, and then in brackets, s1 plus s2. Now if we look back at our circle, we also split up s1 and s2, and it was originally s. So now we can write it out as b equals 2s, because s equals s1 plus s2. So now what we proved here is that b is 2 of s, because s is half of b.